Hello. This lesson in PreCalc is 1:13:16, so you'll be watching that sometime during that day. We're going to look at making a cryptogram, so it's like a coded message using matrices. Cryptogram. To do that, we're going to call the space between words 0 for representing the blank between two words, and the rest of the letters we're going to assign a number to, from A equals 1 down to Z equals 26. So to continue making our coded message, I am going to come up with a message that I want to encode. So I'm going to say, meet me Monday. All right, very important message. All right, so I'm going to, in an uncoded way, make 1x3s. So we're going to change this to a set of 1x3 matrices. So 1 row and 3 columns. So I'm going to take the M, I'm going to grab the 13, the E, I'm going to grab the 5, and the 5. So that's the M, the E, and the next 1 row, 3 columns, 1x3. I'm going to grab the T, 20, the blank, 0, and the M, which is 13. And in like manner, I'm going to write the rest of this in code. So I'm going to get 5, say 1, 2, 3, 1, 2, 3. I'm going to continue. Get 5, 0, 13, and 15, 14, 4. Come back. All right, 15, 14, 4, and 1, 25, 0. The 0 meaning it's at the end of the word. I need to put in 3 in each spot, so I had to fill in with zeros there at the 0 at the end. The last Y was 25. So I had to have a 1x3. So any leftover spots took a 0 there at the end. So that is really uncoded. Anyone could figure that out, that the letters and the numbers would give me that message. So we have to improve on that. To improve on it, we're going to choose a matrix. Let's choose, since this is a 1x3, let's choose a matrix that's a 3x3. It has to be invertible, so it has to be square. And we're going to be multiplying it, so when I have this, I can multiply this by a 3x3, because we know when these match, it can be multiplied. So I'm going to use a 3x3 matrix, and I'll just pick this one. 1 minus 2, 2. Well, negative 1, 1, 3. And 1, negative 1, negative 4. All right. In order to do this one, I'm going to we'll call this matrix A. I already said that. I'm going to multiply A by the first 1x3. So when I do that, I'm going to get 13. The first 1x3 is 13, 5, 5, and I'm going to multiply that by my matrix A. And when I do that, when I have a 1x3 multiplied by a 3x3, I'm going to get a 1x3, which is 1 row and 3 columns. So I'm going to have 3 spots there, 1 row, 3 columns. 13 times 1 plus 5 times minus 1 plus 5 times plus 1 gives me a 13. And now this row, this row and this column, 13 times minus 2 plus 5 times 1 plus 5 times minus 1 gives me negative 26. And the last spot here, this times this, 13 times 2 plus 5 times 3 plus 5 times minus 4. That gives me 21. And you can check that and write out the products and the sums as you go. Alright, so I'm going to do that for every single one of these. So I'm going to take the 20, 0, 13 and multiply it times matrix A. So I'm not going to do it and take up all the video time, but just like I did up here, and I'm going to get 33, negative 53, and negative 12. And then when I take this and multiply it, 5, 0, 13 times matrix A, I'm going to get 18, negative 23, and negative 42. Alright, so I'm running out of space here. So let's see what we got here. So I've got 1, 2, 3 of those. 1, 2, 3. 2 more to multiply out. So the next one was 15, 4, and 4. Times that 3 by 3 matrix A. And when I did that step by step, I got 5, minus 20, and 56. And then the last set was 125, 0 times matrix A gives me negative 24, 23, 27. All right, so if I look on the back and gather all those numbers, I'm going to have 13 minus 26, 21, 33, minus 53, minus 12, 18, minus 23, minus 42, 5 are up to this side of the page, minus 20, 56, minus 24, I know it's gone out of the screen, I'll pull it back in, 23 and 27. So let's see if you can see all those at once. Alright, so that's the code that goes out, and if the people you're sending the code to know what your matrix A is, how can you get back from these numbers to the message? The answer is you're going to take each group, and you know from prior agreement that it's going to be grouped in threes, and you're going to take these 3 and you are going to multiply it by the inverse of matrix A. So matrix A originally was, I'll write it in up here, was 1, negative 2, 2, negative 1, 1, 3, 1, negative 1, negative 4. This is a fairly decent one to find the inverse of. You would add the augmented matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, and then use reduced row echelon form until you come up with it. So we've had that a number of times by now. So I'm going to give you the inverse. So you're going to take the code. This is now coded because this does not represent letter 13 anymore. It's all encoded. So we have 13, negative 26, 21, and we're going to multiply it by A inverse, which I would have to take a moment and figure out. It's negative 1, negative 10, negative 8, negative 1, negative 6, negative 5, 0, negative 1, negative 1. All right, so if I multiply the encoded message by the inverse, look what happens. I'm going to get, this is a 1 row, 3 columns. This is a 3 by 3. So they are multipliable, and we're going to get a 1 by 3. So when I do that, 3 spots here, 13 times -1 plus 26 plus 0 gives me 13. Oops, that's odd. We put a 13 in and got a 13 out. Well, it won't always happen that way. Put in -26, and we're going to multiply this one. It's the first row, only 1 row, second column. -26 times -10 plus -26 times -6 plus 21 times -1 actually comes out to be a 5. And lastly, 13 times -8 plus -26 times -5 plus 21 times -1 also gives me a 5. And I'm going to do that for each of these encoded 1 by 3s. I'm going to multiply it by the inverse of A. And this is code. This is decode or uncoded. So now, when I do that, I'm going to get 13, 5, 5, and I'm going to get to 20, 0, 13, 5, 0, 13, 15, 14, 4, 1, 25, 0, which you will see when you look at the alphabet. This is M, E, E, and if you continue in this process, you will get Meet Me Monday. Very important message that we have to encode. All right, this is just sort of an unusual use for matrices that you might not always hear about. So I wanted to show that to you. So tomorrow I will give you a message to encode, and then I will give you a matrix to use to do that, and then I will give you a coded sequence, and you have to uncode it with the inverse of that special matrix that was agreed on ahead of time. All right, so we're all ready to work for the National Security Agency. See you tomorrow.